Tonight, somewhere in the sky above your roof, a small red point of light is rising. It looks close enough to touch. It is not. Mars is the only world humans seriously plan to walk on next. And yet, almost no one talks about the quiet truth many mission planners have had to consider. The first people who go may never come home. Not because of a disaster, not because anyone abandons them, but because of 4 heavy doors that swing shut behind every traveler. A door made of orbits, a door made of the human body, a door made of machinery that has never been built, and a door made of simple, patient money. Tonight we will walk through all 4 of them slowly, honor by on, all the way down to the red sand. There is nothing to memorize, and no test at the end. So dim the lights. Let your shoulders drop. This is the story of a one-way journey, and why some people will still choose to take it. Let us begin. Hello, and welcome. I am glad you are here tonight. Before we go anywhere near a rocket, or a launch window, or the cold, thin air of another world, take a moment to simply arrive. Maybe you are already in bed. Maybe the house has finally gone quiet around you, and the day is done asking things of you. Maybe this is playing softly on a phone beside your pillow, just a calm voice in a dark room. However you got here, you are in the right place. And for the next few hours, the only job you have is to rest, and to listen, and to let a very large story unfold slowly around you. And because honesty is the foundation this channel is built on, I want to give you one clear promise before anything else. The title of this video says that anyone who goes to Mars will never come back. So, let me tell you plainly what that means. And what it does not mean. It does not mean there is some curse on the red planet, or some secret that space agencies are hiding from you. It means something quieter and, I think, far more interesting. It means that when engineers and doctors and mission planners sit down with the real numbers, the orbits, the fuel, the human body itself, the budget lines, many of them arrive at the same sober conclusion. For the first generation of settlers, with the technology we actually have, the trip to Mars is best understood as a permanent move, not forbidden to reverse, just profoundly, stubbornly unlikely to be reversed, for 4 separate reasons that stack on top of one another. Those are the 4 doors I mentioned a moment ago, and tonight we will stand in front of each one and watch, calmly, how it closes. That is the promise of this video, and everything we cover will serve it. So let us start where the story actually starts. Not on a launch pad. In the human imagination, there is a good chance you have already seen Mars with your own eyes. Even if you did not know it at the time, on a clear night, away from city lights, it appears as a steady point with a faint amber warmth to it, noticeably different from the cool white of the stars around it. It does not twinkle the way stars do, because planets rarely do. It simply glows, patient and unhurried, the way it has glowed over every sleeper in human history. Ancient sky watchers noticed that color thousands of years ago, and something about it unsettled them. The Babylonians associated the Red Wanderer with their god of war and plague. The Romans did the same, and gave it the name it still carries. For most of recorded history, that was all Mars was: a color, a name, a slow ember drifting among the fixed stars. and a vague feeling that it meant trouble. Then telescopes arrived, and the trouble became wonderful. In 1877, an Italian astronomer named Giovanni Schiaparelli pointed his telescope at Mars during an especially close approach and began carefully mapping what he saw. He sketched long, faint, straight features crossing the surface, and he used the Italian word canali to describe them. In Italian, that word simply means channels, natural grooves, the kind of thing wind or ancient water might carve. But when his work was translated into English, canali became canals. And a canal is not a natural thing at all. A canal is dug. A canal has a digger. You can probably feel, even now, half asleep, how much weight one small translation slip can carry. Because across the Atlantic, a wealthy Boston businessman named Percival Lowell read about those canals and became completely, gloriously captivated. Lowell was not a trained astronomer. He was something in some ways more powerful. He was a believer with money. In 1894, he built his own observatory on a pine-covered hill above Flagstaff, Arizona, in air so clear and steady that professional astronomers use the site to this day, and night after night, year after year. Lowell sat at his telescope in the cold and drew maps of an elaborate network of canals. Hundreds of them, converging on dark spots he interpreted as oases. To Lowell, the story those maps told was irresistible, and he told it to America with the energy of a preacher. He imagined a dying world, older than ours, its oceans long gone, and a wise old civilization making one last planet-wide engineering effort, carrying water from the polar ice caps to thirsty cities near the equator. He wrote best-selling books. He packed lecture halls, and the public fell in love. Because Lowell was not really describing a planet, he was describing neighbors, not distant cosmic abstractions, but neighbors with problems, neighbors with public works projects, neighbors who might, on their own clear nights, look back at our blue point of light and wonder about us. For the first time in history, ordinary people could look up at a specific light in the sky and imagine someone looking back. There was only one problem. The canals were not there. As telescopes improved, the network refused to sharpen. Astronomers came to understand that the human eye, straining at the very limit of what an instrument can resolve, tends to connect faint, scattered details into lines that do not exist. The canals of Mars were real in only one place, the human mind. But here is the part I find quietly beautiful, and it is the first genuinely restful thought of tonight. Being wrong did not kill the dream. It planted it deeper. Just 1 year after Lowell built his observatory, a British writer named H.G. Wells began imagining Martians who did not dig canals but came here, and in 1898, the War of the Worlds gave the world its first great alien invasion story. 4 decades later, in October of 1938, a young Orson Welles adapted that novel into a radio drama formatted like breaking news bulletins, and newspapers the next morning claimed that listeners across America had genuinely believed, for one strange evening, that creatures from Mars were walking through New Jersey. Historians who have gone back through the records now argue the panic was smaller than the papers claimed, and honesty obliges me to tell you that, but the deeper fact stands either way. The story was believable at all. By the middle of the 20th century, Mars was no longer just a planet. It was an address. It was where the neighbors lived. And then, in the summer of 1965, the neighbors moved out. That July, a small American spacecraft called Mariner 4 flew past Mars and did something no telescope on Earth could ever do. It looked at the surface up close, and it radioed home 21 grainy photographs. The first close-up images of another planet in human history. The transmission was so slow that engineers at the Jet Propulsion Laboratory in California, too impatient to wait for the official processing, printed out the raw numbers of the first image, pinned the strips to a wall, and colored them in by hand with pastel crayons, like a paint-by-numbers kit, just to see Mars sooner. That hand-colored picture still hangs at the laboratory today. And what the real photographs showed, once they were assembled, was not oases, and not cities, and not canals. It was craters, dry, anciens, silent craters. A landscape that at first glance looked less like a dying civilization and more like the dead face of the moon. The measurements that followed were just as sobering. An atmosphere far too thin to breathe, no global magnetic shield, cold beyond any Antarctic winter. In a single flyby, the inhabited Mars of Lowell and Wells quietly passed away. You might expect that to be the end of the love affair. It was the opposite. And this is the turn that sets up our entire night. The moment Mars stopped being the home of imagined Martians, it became something far more personal. It became a possible home for us. Every mission since Mariner 4 has, in one way or another, been asking a version of the same question. Not is anyone there? Could we be? Could water still be hiding under that rusty soil? Could that thin, poisonous air be turned into something breathable? Could a human being stand in that pink evening light, survive the night, and build a life? Over the coming hours, we are going to answer those questions honestly, with real missions and named studies. And wherever the science is unsettled, I will tell you so plainly. And, chapter by chapter, you are going to watch those 4 doors from the opening swing slowly shut behind our imaginary traveler. Orbits, Bodhi, machinery, money, none of them locked by anyone, all of them heavy, but there is no rush, and nothing to hold on to yet. For now, just keep the image we started with, a small red point of light above your roof, glowing tonight exactly the way it glowed over Schiaparelli at his eyepiece, and Lowell on his freezing Arizona hilltop, and the engineers coloring Mars by hand with crayons because they could not wait to see it. For thousands of years, it was a god of war. For one strange century, it was a neighbor. In the next chapter, we ask the question a child would ask, and we take it completely seriously. How far away is that little red light? Really? The answer is stranger than a number. Let your breathing settle, and we will go find it together. So, let us ask the childish question, and let us honor it, because childish questions are usually the deep ones. How far away is Mars? The honest answer begins with something most people never hear. There is no single answer. Mars is not sitting at a fixed distance from us, the way one town sits at a fixed distance from another. Both Earth and Mars are moving, all the time, on 2 different tracks around the Sun, at 2 different speeds. Earth runs the inner track and completes a lap in 1 year. Mars runs the outer track. And because that track is longer and the planet moves more slowly, a Martian lap takes almost 2 of our years. Picture 2 runners on a track like that, one inside the other. And you can already feel the consequence in your body. Sometimes the runners pass close to each other, nearly shoulder to shoulder. Sometimes they are on completely opposite sides of the loop, with the sun itself standing between them like a bonfire in the middle of the field. At the closest kind of approach, Mars can come within about 35 million miles of Earth. At the farthest, with the sun in between, the gap stretches to roughly 250 million miles. The distance between our two worlds is not a number. It is a tide. It swells and shrinks on a rhythm set by those 2 runners. And nothing any engineer will ever build can change that rhythm, because it is not a limitation of our machines. It is the shape of the solar system itself. Numbers in the millions slide off the mind, especially at this hour. So let me give you gentler ways to hold them, and take them slowly, one at a time. Start with a journey you may have actually taken, a flight across the Atlantic, from New York to London, covers about 3,500 miles in roughly 7 hours. Most people find that flight long. The legs stiffen, the meals blur together, the map on the seat screen barely seems to move. 2005. Now imagine that instead of landing in London, the plane simply kept going, at full airliner speed, day and night, without ever stopping. To cover the distance to Mars, at its very closest, that plane would need to fly not for 7 hours, and not for 7 weeks. It would need to fly for about 7 years. A child boarding that plane in first grade would step off it as a teenager. That is the friendly distance, the closest the tide ever brings us. Of course, rockets are far faster than airliners. So take the fastest trip any humans have ever made. The Apollo missions to the Moon. In the late 1960s and early 1970s, those crews crossed the 250,000 miles to the Moon in about 3 days. 3 days is a road trip. 3 days is New York to Los Angeles, with unhurried stops and good sandwiches. The human body barely registers 3 days. Now hold that road trip in your mind and stretch it with the kind of rockets we actually possess, and using the efficient routes we will learn about in the next chapter. The trip to Mars takes roughly 6 to 9 months. Not 6 to 9 days. Months. That is not a road trip anymore. That is an entire school year. That is a full baseball season. Opening day to the last out of the World Series. Spent inside a cabin about the size of a small apartment, watching one pale blue dot shrink behind you and one faint red dot slowly grow ahead. And there is a third way to feel this distance, and it is the strangest and most important of the 3. So let your shoulders soften while I lay it down gently. Light itself, the fastest thing the universe permits, needs real time to cross the gap between our worlds. When Mars is near, a radio message takes about 3 minutes to travel one way. When Mars is far, that one-way trip stretches past 20 minutes. Roughly 3 to 22 minutes, depending on where the 2 runners are on their tracks. Sit with what that means in practice. A person standing on Mars who asks a question of Earth waits, at the very minimum, 6 or 7 minutes for any possible reply, and often the better part of an hour. There is no live conversation across that gulf. There is no video call where a mother sees her daughter laugh in the same moment the joke lands. There are only messages sent into the dark. and answers that arrive after the moment has already passed. This is not a distant abstraction. NASA lives inside this delay every single day. And one evening in particular shows it perfectly. In February of 2021, when the Perseverance rover plunged into the Martian atmosphere for its landing attempt, the radio delay was about 11 minutes, which means that when the signal saying the descent has begun reached the control room in California, the actual event was already 11 minutes old. By the time the engineers heard that the parachute had opened, the rover had already been sitting on the surface, alive or destroyed, for several minutes. Whatever was going to happen had, in truth, already happened. The people in that room, some of whom had spent a decade of their careers on that machine, were not watching a landing. They were watching the past, and they could not touch it. When the confirmation finally came and the room erupted, they were celebrating an event that Mars had already finished with. That is what 50 million miles feels like from the inside. Now, gather the three pictures together, because side by side they say something no single number can. 7 years by airliner, a full school year by rocket, and even for light itself, long minutes of silence. Mars is close enough to see with your bare eyes tonight, and far enough that the present moment cannot stretch between here and there. Two worlds, permanently out of sync, sharing a sun but never quite sharing a now. And here is the final thought of this chapter, the one that opens the door to everything that follows. If the distance to Mars behaves like a tide, swelling and shrinking on a 2-year rhythm, then traveling to Mars is not like driving, where you leave whenever you please. It is like sailing in the oldest sense. You do not leave when you wish. You leave when the tide allows, and the tide, for Mars, allows it only once, roughly every 26 months, in a window just a few weeks wide. Miss those weeks, and the window does not shrink. It vanishes entirely. For more than 2 years, every robot we have ever sent to Mars has obeyed that rhythm without exception. In the next chapter, we will find out exactly why the rhythm exists, and we will meet the quiet German engineer who worked it all out with pencil and paper, decades before the first rocket ever reached space, because hiding inside his beautiful, patient mathematics is the first of our 4 doors, the door made of orbits, and it is time to watch how it swings. There is still no hurry. The tide will wait for us tonight. Our story now needs its first hero, and he is not an astronaut. He is a shy civil engineer with a beard and a day job, and he changed spaceflight forever without ever leaving the ground. His name was Walter Hohmann, and he lived in the German city of Essen, where he worked for the city government as a building engineer, the mathematics of bridges, foundations, and loads. By day, he inspected structures, but in the evenings, in the years around the First World War, Hohmann gave his spare hours to a question that had no practical use whatsoever at the time. If a machine ever did travel between planets, what path should it take? Rockets barely existed. Space travel was pulp fiction. And yet this quiet municipal engineer filled notebook after notebook with orbital mathematics, purely because the question would not leave him alone. In 1925, he published the work as a small book, and in it he described the most fuel-efficient path a spacecraft can ever take from one planet to another. Engineers still call it the Hohmann transfer orbit. and a century later, it remains the backbone of almost every Mars mission ever flown. The man who drew the road to Mars never saw a single rocket use it. But every machine we have ever sent there has, in a real sense, been following his pencil lines. And his idea can be understood perfectly while lying down with your eyes closed. In fact, it may be easier that way. So settle a little deeper and picture it with me. Forget rockets for a moment. See the sun, warm and heavy at the center of everything. Around it, Earth's orbit is a small ring. Mars's orbit is a larger ring outside it. A Hohmann transfer is simply a gentle arc that touches both rings. It kisses Earth's ring at the start, swings outward in one long lazy curve, and kisses Mars's ring on the far side of the sun. One firm push of the engines to leave the small ring. Then months of silent, unpowered coasting along the arc. Then one more push at the far end to settle onto the big ring. That is the entire trick. In between the two pushes, the spacecraft is not flying in any active sense. It is falling, the way a thrown ball falls. Except the throw lasts most of a year, and the catcher is a planet. The beauty of this path is that it wastes almost nothing. The curse of this path is everything else about it. And the curse is where our story lives, because the arc only works if Mars is actually standing at the far end when the spacecraft arrives. And since the coast takes 6 months or more, Mars must be in a very particular position on launch day, running ahead of Earth by just the right angle, so that planet and spacecraft reach the same point in space at the same moment. Spacecraft do not travel toward planets. They travel toward appointments. Engineers aim at an empty point in the darkness, a point where nothing exists on launch day, trusting the clockwork to deliver a planet there on time. Every successful Mars landing in history has been a rendezvous with a place that did not exist yet when the journey began. That precise required geometry, Earth here, Mars there, is what mission planners mean by a launch window, and the two planets, on their two different laps, only return to that geometry about once every 26 months. Nobody chose that number. No agency can appeal it. It falls straight out of the arithmetic Walter Hohmann did in his evenings in Essen. And when you hear that NASA is targeting the 2026 window or the 2028 window, this is the clock they are reading. The solar system publishes a ferry schedule, and it has exactly one departure every 2 years and 2 months. Now, breathe slowly here, because this is where the night makes its first real turn. Everything so far describes the trip out. But this is a story about coming home. So imagine our traveler has crossed the arc, survived the landing, and is standing in the rust-colored dust, watching a small bright evening star that is Earth. Ask the only question that matters tonight. When can they come back? And the clockwork gives its patient, indifferent answer, not now, because the return trip is just another Hohmann arc, this time from the outer ring to the inner one, and it demands its own alignment. Earth must be positioned to catch the falling spacecraft at the end of its long inward curve. And at the moment our traveler lands, the planets are nowhere near that arrangement. In fact, the very geometry that made the outbound trip possible is what makes an immediate return impossible. The alignment that opened the door out is, by its nature, the wrong alignment for the door back. Having just walked through, our traveler turns around and watches the door swing gently, completely shut. How long until it opens again. Mission planners have run these numbers for decades. And, for the efficient class of mission, the answer is remarkably consistent. The crew must wait on the surface of Mars for roughly 400 to 500 days, well over a full year, before the geometry for the ride home returns. Add the 6 to 9 months outbound and the 6 to 9 months back, and the shortest sensible round trip comes out to roughly 2.5 to 3 years. Door to door. There does exist a faster style of mission on paper, one that cuts the surface stay to a month or two, but it punishes the crew with a longer and harsher route home, swinging inward past the orbit of Venus, closer to the Sun, with more radiation and more months in the void. Most serious mission designs reject it. The slow way is the safe way, and the slow way means more than a year of waiting on Mars. No matter what, I want you to feel the true shape of that, because it is the first full layer of our title. From the second the boots touch the dust, there exists no version of events, none, in which that person stands on Earth again in less than about 2 years. Not if they are homesick, not if a parent falls ill, not if the entire crew simply changes its mind on the first night. The door made of orbits does not take requests. It opens every 26 months, holds for a few weeks, and rests shut the remainder of the time, as it has since long before anyone was here to mind. And notice what that enforced waiting quietly becomes, because this idea will follow us all night. A crew that must survive on Mars for 400 days cannot camp. They must harvest power, coax water from frozen ground, manage every breath of air, repair their own machines. In short, they must begin to settle, whether they intended to or not, simply to live until the ferry returns. The requirement to wait becomes a requirement to build, and everything they build, every tank and cable and greenhouse, makes the settlement stronger and the leaving heavier. Hold that thought loosely, like something warm. We will need it again near the middle of the night. But, before any of that, our traveller has to survive the crossing itself. 6 to 9 months of falling through silence, inside a body that was carved by 4 billion years of gravity, suddenly living with none at all. What weightlessness actually does to bones, to muscles, to the human heart, is stranger than most people have ever been told. And the best evidence we have comes from an experiment nature almost seemed to design for us. A pair of identical twin brothers, both astronauts, one sent to space for a year while the other stayed home. Their story is next. You have nowhere to be, and the falling is quiet. Let us drift with it. From the outside, the long crossing looks peaceful. Weightlessness looks like play. We have all seen the footage from the International Space Station. Astronauts drifting through sunlit modules, tumbling in slow motion, chasing a wobbling sphere of floating water, wearing that easy grin that only zero gravity seems to produce. It looks like the most restful thing a human body could ever do. Float, carry nothing, never climb a single stair. If you have ever ached at the end of a long day on your feet, some part of you has probably envied them. But here is the quiet irony at the center of this chapter. Your body does not experience weightlessness as rest. It experiences it as a message. And the message, delivered silently, hour after hour, is this: gravity is gone, and therefore strength is no longer needed. To understand why that message is so dangerous, you have to notice something about yourself that is easy to miss, precisely because it never stops being true. Your body is not a finished object. It is an ongoing negotiation with gravity. Every bone in you is living tissue, constantly being torn down and rebuilt by specialized cells. And the signal that tells those cells how strong to build is the daily stress of load. Standing loads your spine. Walking loads your hips. Carrying groceries loads your arms. Right now, lying still, the gentle press of your own weight into the mattress is data, and your skeleton is listening to it. Remove all of it, and the body does something perfectly logical and quietly devastating. It begins dismantling what it believes it no longer needs. Biology does not keep what is not used. It never has. This is not theory. It has been measured on real people for decades, and the numbers deserve to be heard slowly. Astronauts aboard the International Space Station lose bone mineral density at a rate of roughly 1 to 1.5% per month in the weight-bearing parts of the skeleton. The hips, the spine, the legs. Let that rate find its scale. On Earth, an older adult with osteoporosis, the bone-thinning disease we treat as a serious medical condition, might lose that much bone in an entire year. An astronaut in orbit can lose it in a month. Over a 6 to 9 month crossing to Mars, a crew member could arrive having shed a meaningful fraction of the bone strength in the very legs and hips they will need for standing on a new world. Muscle obeys the same logic, only faster, without resistance. The large muscles that hold you upright, the back, the thighs, the calves, begin visibly weakening within days, because in space they are asked to do almost nothing at all. Even the heart, which is itself a muscle, gets the message. In weightlessness, the heart no longer fights to pump blood upward against gravity, and so, like everything else, it can ease off and grow slightly smaller and less powerful over a long mission. The body is not failing when it does this. The body is adapting, beautifully and efficiently, to the void. The tragedy is only that the void is not where the journey ends. This is why, if you watch life aboard the space station, you will see something that looks strange for people floating in paradise. Astronauts strap themselves to treadmills with bungee harnesses. They pedal bicycles that go nowhere. They pull against resistance machines. Around 2 hours of it. Every single day. 6 days a week. None of that is fitness culture. It is a holding action, a daily argument with their own biology. And here is the sobering part. Even with all of it, the losses are slowed, not stopped. Now, the deepest look science has ever taken into what long spaceflight does to a human being came from an experiment that sounds like the setup of a novel, and every word of it is documented. NASA had, among its astronauts, a pair of identical twin brothers. Their names are Scott Kelly and Mark Kelly. Identical twins share essentially the same genetic blueprint, which makes them precious to medicine, because differences that appear between them can be traced to their environments rather than their genes. And so, in March of 2015, NASA launched Scott Kelly to the International Space Station for a mission lasting nearly a year, 340 days, while his brother Mark remained on Earth, living an ordinary retired astronaut's life. Same genes, two worlds. Scientists at universities across America studied both men before during, and after in a project NASA called the Twins Study, and the results were published in the journal Science in 2019. Some of what they found was almost funny. Scott returned from orbit about 2 inches taller than his brother, because without gravity compressing it, the human spine relaxes and lengthens. The extra height vanished within days of landing, gravity reclaiming its tax. But most of the findings were not funny at all. During the mission, the fluid of Scott's body no longer pulled downward, shifted toward his head, changing the shape of his eyes and affecting his vision. A problem now recognized in many long-duration astronauts. The walls of his arteries showed changes. The activity of thousands of his genes shifted, most of it settling back after landing. A small portion still altered 6 months later. His immune system behaved erratically, and I want to be honest about the other side of this ledger too, because the twins study was not a horror story. Its deepest finding was that the human body is astonishingly adaptable, that Scott Kelly could live nearly a year in the void and return, recover, and be fundamentally well. Human biology bends remarkably far without breaking. That resilience is real. It is measured, and every hopeful plan for Mars rests on it. But now place the twin study next to the journey we are actually describing tonight, and feel the gap. Scott Kelly spent his year a few hundred miles above the Earth, inside its magnetic embrace, with fresh supplies arriving by cargo ship, with a medical team, a phone call away, and a ride home always docked just outside. A Mars crew will have none of that. Their year in weightlessness is not the mission. It is only the commute, the opening act, with a harsher world waiting at the end of it and no ride home docked anywhere at all. So picture our traveller once more, drifting along Walter Hohmann's long, quiet arc, and see the journey with new eyes. The body floating so peacefully is not resting. It is quietly reorganizing itself for a world without weight, thinning its own bones, letting its muscles fade, gentling its heart, becoming, day by day, a creature of the void. This is the second of our 4 doors beginning to move. The door made of the body itself. And unlike the door of orbits, this one has no schedule and swings only one way. It does not open again every 26 months. It only closes further, at the speed of adaptation, one heartbeat at a time. Let your own heart beat slow a little here, because there is one more truth about the crossing, and it is the strangest of them all. Everything in this chapter, the bones, the muscles, the drifting fluids, can at least be fought, with straps and treadmills and stubbornness. But there is something else out there on the ark, something that passes silently through the hull of the spacecraft and through the traveller inside it, that no treadmill can touch and no muscle can resist. The astronauts of Apollo met it half a century ago, in the dark, with their eyes closed. And what they saw when they should have seen nothing at all is where our story goes next. On the way to the moon, in the summer of 1969, the astronauts of Apollo 11 noticed something odd. When they closed their eyes to sleep, the darkness was not entirely dark. Every so often, perhaps once a minute or two, a tiny streak or flash of light would fire silently across their vision, like a distant spark, with their eyes shut, inside a darkened spacecraft. Buzz Aldrin reported it, and crews on later missions confirmed it again and again. The flashes were eventually explained. and the explanation is worth a slow breath. They were cosmic rays, individual particles from deep space, so energetic that when one passed through the astronaut's eyes, or the visual centers of their brains, the nervous system registered it as light. The travelers were not seeing something outside the window. They were seeing the radiation of the galaxy passing through their own heads. Nothing about a human body evolved to notice that. And that is the subject of this chapter. The danger with no color, no sound, no weight, and no warning. And the reason it belongs to Mars is a gift you have been receiving every second of your life, without ever once feeling it, deep beneath the floor of your bedroom, thousands of miles down. The core of the Earth is an ocean of molten metal, slowly churning. That motion generates an enormous magnetic field that wraps the entire planet and reaches far out into space. We almost never think about it. A compass needle twitching toward north is the only everyday hint it exists. But that invisible field is one of the quiet reasons you are alive tonight. Streaming constantly from the sun is a wind of charged particles, and sleeting in from the deeper galaxy are rarer, far more energetic particles, born ages ago in the explosions of dying stars. Much of this would be harmful to living tissue, and for billions of years, Earth's magnetic field has been catching it, bending it, and steering most of it harmlessly around the planet. Like a great, invisible umbrella held over every living thing. Above that, our thick atmosphere absorbs most of what slips through. You have spent your entire life at the bottom of two nested shields, so effective that your species needed most of its history just to discover they were there. Now send our traveler beyond both of them. The moment a spacecraft climbs past the reach of Earth's magnetic field, the umbrella is gone, and it does not return until the traveler comes home, out on the long arc to Mars. A human body meets two kinds of radiation at full strength. The first comes from the sun, especially during sudden eruptions called solar particle events, when the sun flings a dense burst of energetic particles across the solar system, sometimes with only minutes to hours of warning. For these, at least, there is a defense. A well-designed spacecraft can include a heavily shielded corner, a storm shelter, often surrounded by the ship's own water tanks, where the crew can wait out the worst of a solar storm. Solar outbursts are dangerous, but they are weather, and weather can be sheltered from. The second kind cannot. It is called galactic cosmic radiation, the same deep space particles that painted flashes inside the closed eyes of the Apollo crews. It arrives thinly but constantly, from every direction at once, every hour of every day of the entire journey. And some of its particles carry so much energy that stopping them is beyond any practical spacecraft. Here the story turns genuinely strange. So let it come slowly. Ordinary shielding, more metal, thicker walls. The instinctive answer can actually make this radiation worse. When one of these extremely energetic particles strikes a thick barrier, it can shatter into a spray of secondary particles, like a rifle bullet hitting stone and becoming shrapnel. A wall of the wrong thickness does not block the storm. It multiplies it. Against galactic cosmic radiation, the crew's real shield is not armor at all. It is the calendar, the less time spent exposed. The smaller the dose, which is one more quiet reason the long, slow beauty of Hohmann's arc is also its curse. And we are not guessing about any of this, because we have measured it. On the actual road to Mars, when NASA launched the Curiosity rover in November of 2011, the spacecraft carried an instrument called the Radiation Assessment Detector, and during the 8-month cruise to Mars, that instrument did something invaluable. Tucked inside the capsule, roughly where a human crew would sit, it simply recorded the radiation coming through. The results, published by the mission's scientists in the journal Science in 2013, allowed the first hard estimate of what a human crew would absorb. The finding was stark. The radiation dose from a single round trip to Mars, before even counting time spent on the surface, would approach or consume a large share of the total exposure that NASA permits an astronaut across an entire career. Read that again, slowly, the way the scientists had to. One mission, spending most of a professional lifetime's safety budget. What does such radiation actually do inside a person? Here the promise of this channel matters most. So I will separate what is established from what is feared. Cleanly, what is established is this: radiation damages the fine structure of cells, and elevated exposure raises a person's lifetime risk of cancer. That link is solid science, and it is already enough, on its own, to rank radiation among the central medical problems of any Mars mission. What is feared, but not yet established, goes further. Studies exposing laboratory animals to this kind of radiation have raised concerns about possible effects on the heart and blood vessels, and some research has raised questions about gradual effects on the brain. Scientists studying these possibilities are careful to say the human picture is not yet clear, and I will be exactly as careful. These are open questions, under active study, worrying enough to research, and unproven enough that honesty forbids stating them as fact. Engineers, for their part, are not standing idle, and the list of ideas is genuinely encouraging. Water walls, storm shelters, faster transit designs, habitats on Mars buried under yards of soil, letting the planet itself become the shield. Some of these will likely work well, but notice what every one of them shares. They manage the dose. None of them cancels it. Radiation, for the foreseeable future, is not a problem Mars travelers solve. It is a cost they pay, silently, by the day. So let the two chapters of the crossing settle together now, side by side, like two weights on the same side of a scale. For every day of those 6 to 9 months, the traveler's bones are quietly thinning, and the galaxy is quietly writing its signature into their cells. No alarms, no drama, no single terrible moment, which is exactly what makes it all so serious. Both costs are slow, both are cumulative, and both travel in only one direction. And when the falling finally ends, and the red world rises up to meet them, the traveler arrives weaker than they left, carrying an invisible ledger of exposure, and looks out at the landscape that is supposed to be the reward. What waits outside that window is a world of real and unexpected beauty. It is also, in at least 4 distinct and patient ways, a world that is trying to end them. The next chapter is about that world, its poisoned ground, its vanishing warmth, and the storm that once swallowed the whole planet and silenced a beloved machine that had refused to die for 15 years. Breathe out slowly. We are about to land. After months of falling, the falling ends. Our traveler descends through a thin pink sky, fire and deceleration, and then stillness. And for the first time in most of a year, there is ground, real ground, running out to a horizon, with hills and shadows and small stones casting long morning light. The photographs sent home by rovers over the past 20 years have made this landscape strangely familiar to all of us. Rusty plains scattered with dark rocks, wind-sculpted dunes with edges soft as suede, evening skies that glow rose and gold and fade to a deep, quiet blue. It is, by any honest account, beautiful. Scientists studying the rover images often remark that the terrain looks like the deserts of the American Southwest, like Arizona or southern Utah, someplace a person could walk with a water bottle and a wide-brimmed hat. That resemblance is the most dangerous illusion on Mars. And this chapter is about seeing through it, gently, one layer at a time. There are 4 layers. Any one of them, alone, would be enough to keep every human being indoors forever. Let us take them the way the evening takes the light. Gradually, the first layer is the air, or rather, its almost total absence. The atmosphere of Mars is roughly 1% as thick as the air filling your lungs right now. 1%. To find air that thin on Earth, you would have to rise to about 3 times the height of Mount Everest, into altitudes where no unprotected human remains conscious. And even that comparison flatters Mars, because the little air it has is about 95% carbon dioxide, useless to human lungs from the very first breath. A person stepping outside without a pressure suit would not endure a long cinematic struggle. Consciousness would simply dim and go out within seconds, the body finding nothing at all to work with. On Mars, every breath of every hour of every year, for the rest of a settler's life, is manufactured by a machine. We will meet that machine later tonight, and its story is one of the most hopeful in this entire journey. But its work can never pause. Not once. The second layer is the cold, and the cruelty of it is not the temperature itself. It is the treachery. Mars orbits about half again as far from the Sun as Earth, and its wisp of an atmosphere holds warmth the way a window screen holds water. On a generous summer afternoon at the equator, the ground can briefly warm to something like a mild spring day, and a thermometer in the sunlight might read a temperature you would happily picnic in. But the instant the sun sets, the warmth simply pours off the planet into space, unimpeded, and the night plunges far below the coldest nights of Antarctica. The average temperature across the whole world sits around 60 degrees below zero. A settlement, therefore, is not merely heated the way your home is heated for comfort. It is heated the way a heart beats. On Mars, losing power at nightfall is not an inconvenience. It is a countdown measured in hours. The third layer is the one almost no one outside planetary science ever mentions, and it hides in the most innocent-looking thing on the planet, the soil itself. In May of 2008, a NASA lander named Phoenix touched down on the far northern plains of Mars, reached out a robotic arm, and did the simplest thing in the world. It scooped up a handful of dirt and analyzed it, and in that dirt, mixed through it, Phoenix found significant amounts of chemicals called perchlorates, reactive salts that are toxic to human beings, known on Earth to interfere with the thyroid gland. Findings since then have supported the conclusion that these salts appear to be widespread across the planet. Now marry that fact to the dust, Martian dust is extraordinarily fine, finer than talcum powder, ground for billions of years, with no rain to wash it into clay and no streams to carry it away. And it clings to everything through static charge. The Apollo astronauts learned on the moon how relentlessly such dust invades. Coating suits, floating in cabin air, grinding into seals and hinges, and the moon's dust is at least chemically dull. En masse, the clinging dust is laced with poison. Every single trip outside for the rest of a settler's life ends at an airlock where an invisible toxin must be brushed, filtered, and fought. The enemy is not a monster. It is laundry. Forever. With lives depending on it. And the fourth layer arrives on the wind. And for this one, I want to tell you about a machine. Because the machine makes it real in a way no statistic can. Her name, informally, around the Jet Propulsion Laboratory, was Oppie. Formally, she was the rover Opportunity, and she landed on Mars in January of 2004 with a design lifetime of 90 days. She lasted almost 15 years. She drove a marathon's worth of distance across the plains, survived dust storms and dune traps and a frozen wheel, and became, for the team that drove her each morning, something perilously close to a colleague. Then, in June of 2018, one of Mars's planet-swallowing dust storms began to rise. Most Martian dust storms are local, passing squalls. But every few years, in a pattern scientists still cannot reliably predict, the storms merge and grow until they wrap the entire planet in a single shroud. And the 2018 storm became one of the thickest ever observed. Above Opportunity, the sun dimmed and dimmed and disappeared. She was solar-powered. Her last transmission, in the first days of the storm, reported falling power and rising darkness. And one journalist's translation of that final telemetry traveled around the world and made millions of people grieve for a robot. My battery is low, and it is getting dark. Those were not literally her words. And honesty makes me tell you that they were a reporter's poetry wrapped around real data. But the data itself said the same thing. The storm did not clear for months. When the skies finally opened, the team at JPL began calling her, listening through the deep space antennas for any reply. And they kept calling, command after command. Song after song beamed across the void. More than 1,000 attempts through the autumn and winter. Nothing ever came back. In February of 2019, NASA formally declared the mission complete, and grown engineers wept at the podium. A dust storm on Mars had ended. In 8 months? What 15 years of cold and grit could not? And Opportunity was a machine, needing no food, no water, no warmth for sleeping children. A human settlement, drawing power from the same darkened sky, would have been racing that same storm with lives aboard. So now stack the 4 layers, gently, and see the single shape they make. Air that must be manufactured, without pause. Warmth that must be generated, without pause. Ground that is quietly toxic, forever. And a sky that, every few years, may switch off the sun for months without warning. None of this makes Mars impossible. And I mean that without any irony. Engineers have serious, developing answers for every single layer. And some of those answers are already working on Mars tonight. But notice, And this is the honest heart of the chapter. What every answer has in common: habitats, airlocks, filters, reactors, buried shelters. Every solution to Mars is a way of living indoors. On a world where outdoors is never truly yours, a settler may walk the surface, and the surface is magnificent, but only ever as a visitor in a sealed suit, on a schedule, through an airlock, for the rest of their days. And yet, strangely, none of these 4 layers is the thing that may most deeply and permanently separate a settler from the world they left. That thing is quieter than the storms, subtler than the poison, and it cannot be filtered, shielded, or buried away, because it is not in the air or the soil. It is the planet's own gentle grip. When our traveler took that first step onto the sand, something felt wrong in a way they could not immediately name. Their boots pressed down too lightly. Their tools swung too easily. Everything they carried, including their own bones, weighed only about 1/3 of what it should. Let your hands rest heavy on the blanket for a moment, and feel what they weigh. That familiar heaviness is about to become the strangest character in our story. Notice, if you are still drifting near the surface of wakefulness, the weight of your own hand resting on the blanket. That gentle, constant heaviness has been with you every moment of your life. You were born into it. You learned to lift your head against it, then to crawl through it, then to stand up inside it. And the day you managed that, every adult in the room applauded, because standing against the pull of the earth is the first great victory of every human life. Every bone in your body was built to the exact specification of that pull. Your heart was sized for it. Your feet are shaped for it. The heaviness of your hand right now is not something happening to your body. In a very real sense, it is your body. The force, your whole frame, was carved to answer en masse. That force is only about 38% as strong. A person who weighs 160 pounds on Earth weighs about 60 pounds there, and in the beginning, for our newly landed traveler, this would feel like nothing but mercy. After months of weightless wasting, they can stand. They can walk on the first day, bounce on the second, carry loads that would stagger a strong person back home. Of all the hardships Mars offers, its light gravity looks, at first glance, like the one kindness, the one place where the red planet goes easy on its guests. But tonight, we have learned to be patient with first glances. So let us ask the question that matters, the one this entire chapter turns on. What does 38% gravity do to a human body? Not over a week, but over years and over decades. And here I owe you the plainest sentence in this entire video. Nobody knows. That is not a dramatic flourish, and it is not modesty. It is a precise description of the current edge of human knowledge. And it is worth seeing exactly how strange that edge is. Consider what our species has actually tested. We have total experience of 100% gravity. That is all of human history. Every body that has ever lived. We have decades of hard-won data on zero gravity from space stations. And we know in detail how it slowly dismantles bone and muscle, because we watched it happen to Scott Kelly and to hundreds of others. And between those two well-studied points, between 100% and zero, our species has almost nothing. The only human beings who have ever lived in partial gravity were the Apollo astronauts walking the moon at about 17% of Earth's pull, and the longest any of them stayed was barely 3 days. 3 days, half a century ago. That is the entire experience of the human race, with every level of gravity between none and all. Mars settlers would live at one of those untested levels for the rest of their lives. In the most literal sense, the first settlers will not just be explorers. They will be the experiment, scientists, unable to run that experiment yet, have probed it from the edges, and the honest picture is worth laying out. On Earth, researchers run long bed rest studies, paying volunteers to lie tilted slightly head down for months at a time, because a body lying down unloads its bones and mimics some of what weightlessness does. Aboard the space station, experiments have spun mice in centrifuges that simulate partial gravity, including levels near Mars's, to see whether the pull is enough to protect their bones and muscles. Some of that animal work offers cautious hope, suggesting partial gravity slows the losses compared to weightlessness. None of it settles the question for human beings across years, so the field is left holding two open possibilities. And I will give you both, because you deserve both. The hopeful possibility is that 38% is enough. Enough load to tell the skeleton it is still needed. Enough work to keep the heart honest. And that settlers' bodies would stabilize into a lighter but healthy new normal. The concerning possibility is that the body reads Martian gravity as merely a slower version of the void, and that bone and muscle and heart continue quietly downhill, year after year, politely and without symptoms, the way they do in orbit, just at a gentler grade. Now follow that uncertainty to the place where it meets our title, because this is where the second door of our 4 clicks, softly, toward, shut. Suppose a settler lives on Mars for 5 years, or 10. Suppose the concerning possibility is even partly true, and their skeleton has spent a decade renovating itself downward toward Martian sufficiency, their heart easing into a lighter workload, every tissue settling comfortably into a gentler world. Now put that person on the rocket home. The return crossing immediately adds 6 to 9 more months of full weightlessness, subtracting strength from a body that has less to spare than any traveler in history. At the worst possible moment, right before the hardest test, because at the end of that crossing waits Earth, full, relentless, 100% Earth, the heaviest environment that body will have felt in a decade. We already know what Earth does to astronauts returning from just 6 months in orbit. Many cannot walk unaided on the first day. They are lifted from the capsule and set in reclining chairs, dizzy, trembling, their own blood suddenly heavy in their legs, and they face weeks of supervised rehabilitation with the entire medical infrastructure of a planet standing by. Medical researchers, looking further ahead, have raised the sober concern that a body adapted to years of Martian gravity might meet the return to Earth not as a difficult recovery, but as a genuine physical danger. Bones more vulnerable to fracture under sudden full weight. A heart strained by circulation it no longer remembers how to lift. And precision matters here. So let me mark the boundary clearly. No such returning settler has ever existed. So this outcome has never been observed. And it is a concern that serious scientists take seriously rather than a proven fact. But notice the direction it leans, because it is the same direction everything tonight leans. The longer a settler stays, the more thoroughly their body becomes Martian, and the heavier the door home becomes. Time itself takes a side, and there is one more turn of this idea, the gentlest and the strangest, and I will only open it tonight, not finish it. Everything we have said describes an adult, a body finished by Earth before it ever left. But someday, in some warm buried room on that cold world, a child may be born on Mars, a body built from its very first cell, under 38% gravity. No such child exists, and the science of human development in partial gravity is one of the great unknowns, studied so far only in cells and small animals. So every word here must stay conditional, and it will. But researchers who think about that child suggest their bones, their heart, their whole frame might grow shaped for a lighter world, sufficient for Mars, and perhaps never sufficient for Earth. If that proves true, then, for such a child, the question of going back would not even be a question of recovery. Earth would simply be a beautiful blue star where the old stories happened. A world their own body was never built to visit. Hold that child gently in the back of your mind, near the end of tonight, when the hard doors are all behind us. We are going to meet them properly. At a window, at dusk. For now, our traveller stands in the amber evening light of a smaller sun, lighter than they have ever been in their life, on a world that is quietly, patiently, making their body its own. They can live here, but living here requires the one cargo no ship can carry enough of: air for every breath, water for every day, food for every season, produced on Mars, from Mars, forever. And the story of how that becomes possible begins with a machine the size of a car battery, humming to itself on the floor of an ancient crater, doing something no machine had ever done in the history of other worlds. It made air, and it is waiting for us, just on the other side of this breath. Every great turning point in history has a sound, and most of them are quieter than we expect. The sound of this one was a hum, a small mechanical hum, coming from a gold-plated box about the size of a car battery, bolted inside the belly of a rover, sitting on the floor of an ancient crater 50 million miles from the nearest human being. It is the 20th of April, 2021. The rover is Perseverance, and it landed just 2 months earlier in a place called Jezero Crater, a basin that billions of years ago held a lake fed by a river. On this particular day, engineers on Earth send a command across the radio gap, and after the long minutes of light delay, the little gold box wakes up. It draws in a thin, freezing breath of Martian air. It warms that breath to around 800 degrees Celsius, and then it begins, molecule by molecule, to take the air of Mars apart. The box is called MOXIE, and NASA chose the name with a certain sense of humor, because MOXIE is an old American word for stubborn, cheerful courage. The formal name is the Mars Oxygen In Situ Resource Utilization Experiment, which is a long way of saying something simple and almost unbelievable. MOXIE was built to make oxygen on Mars, out of Mars. Here is how it works, and the idea is gentle enough for this hour, so let it come slowly. Remember that the Martian air, thin as it is about 95% carbon dioxide. A molecule of carbon dioxide is one carbon atom holding hands with 2 oxygen atoms. The oxygen a human body needs is locked inside that molecule, the way lumber is locked inside a tree. MOXIE is, in a sense, a very small, very hot sawmill for air. It pulls in carbon dioxide, compresses it, heats it, and uses an electrical process to split the molecules apart, releasing carbon monoxide back into the sky and keeping the pure, breathable oxygen behind. No tanks shipped from Earth, no pipeline, just local air, electricity, and chemistry. Behind that box was a team, and the team deserves a place in this story, because machines do not dream themselves up. MOXIE was led by a scientist named Michael Hecht of the Massachusetts Institute of Technology, working with engineers at MIT and at the Jet Propulsion Laboratory in California, and the group spent the better part of a decade shepherding the idea from sketches to hardware. Hecht liked to describe the project's ambition in the plainest possible terms. Future explorers, he pointed out, will not need oxygen mainly for breathing. They will need it in vastly larger amounts to burn as rocket propellant for the trip home. His little box was never meant to be the answer. It was meant to be the question, asked out loud on another planet for the first time. Can it be done at all? On that April day in 2021, the answer came back across the void. Yes. In its first hour of operation, MOXIE produced about 5 grams of oxygen, roughly 10 minutes of breathing for one resting astronaut. 5 grams. And when the confirmation reached Earth, the team celebrated the way people celebrate a first step, not a finish line, because the amount was never the point. The point was the principle. For the entire history of spaceflight, every breath any human has taken beyond Earth was a breath carried from Earth, bottled, launched, and rationed. April of 2021 was the first time in history that a machine standing on another world made the stuff of life from that world's own sky. If human beings ever do live on Mars, the historians among their descendants may trace the first thread of their whole civilization back to those 5 quiet grams. And MOXIE did not stop there. Over the following 2.5 years, it ran again and again. 16 times in all. In Martian winter and Martian summer. By day and by night. Deliberately testing itself across the full range of the planet's moods. It exceeded its own design goals. At its best, producing about 12 grams of oxygen in an hour. By the time NASA announced the experiment's successful completion in September of 2023, MOXIE had generated roughly 120 grams of oxygen in total, and the agency said plainly that the next step would not be another small experiment, but the design of full-scale systems that future missions could actually rely on. So let this stand, in the middle of our long, careful night, as a genuine piece of good news, because it is the single most immediate problem of living on Mars. The problem of the next breath has a demonstrated, working, measured answer. The air of Mars can be mined. Breathe in slowly, right now, and notice how effortless that was. En masse. That same breath will be an industrial product, but it will exist. And yet the promise of this channel is to show you whole truths. So now we must do the gentle, necessary arithmetic, and place 2 numbers side by side in the dark. The first number is 120 grams. The entire lifetime production of the most successful oxygen machine in the history of other worlds. The second number comes from NASA's own studies of the rockets that would carry a crew off the Martian surface. The machines we will meet properly in 2 chapters. Those studies estimate that a single crewed launch from Mars would require somewhere in the neighborhood of 25 to 30 metric tons of liquid oxygen. Don't set the 2 numbers beside each other and let them speak. The celebrated career total of MOXIE amounts to less than 100,000th of what one ride home requires. That is not a criticism of MOXIE. And I want to be fair to the little machine, because it did exactly what a Pathfinder is supposed to do. And the people who built it earned every headline. It is simply the honest scale of the road ahead. Making air for lungs is nearly within reach. A matter of building MOXIE's descendants larger and running them steadily. A crew of 6 needs a few kilograms of breathing oxygen a day. And engineers speak of that goal with real confidence. Making air for engines is something else entirely. It is a factory, a chemical plant running day and night for years, fed by a power station, maintained by no one, on a world where the nearest spare part is, at best, 1 launch window and half a year away. The distance between those 2 goals, between the breath and the rocket, is the distance this whole night has been quietly walking toward. But a settlement does not live on oxygen alone. And before we stand before the rocket, we owe our settlers the other 2 pillars of any human life: water and food. One of them is hiding under the rust-colored ground in quantities that surprised the very scientists who found it. Frozen there since before our species existed. The other must be coaxed, leaf by leaf, out of soil we already know is laced with poison. Let your breath find its own easy rhythm again. The next part of the journey is about the oldest things people have ever needed. And it begins, as it always has, with the search for water. Every desert people in human history has known the same first law. Before shelter, before fire, before anything else, find the water. The Bedouin knew it. The peoples of the Sahara and the Kalahari knew it. The settlers crossing the American West knew it, sometimes learning it in the hardest possible way. And so, as our settlers look out across the rust-colored plains, red dust running to every horizon, the oldest question our species knows travels with them. Where is the water on a world that looks like it has never once seen rain? The beautiful answer is that Mars used to be soaked in it. And this is not speculation. It is written into the rocks. And our robots have spent 20 years reading it aloud to us. Rovers have photographed rounded pebbles of the kind that only form when they tumble down a flowing stream. Orbiters have mapped winding riverbeds, broad deltas, and the ghostly shorelines of vanished lakes, and, some researchers argue, of an ancient northern ocean, Jezero Crater, where Perseverance rolls tonight and where MOXIE made its first breath of oxygen, was chosen as a landing site precisely because it was once a lake, with a river delta spilling into it that is still visible from orbit. Dry as bone, patient as stone, billions of years ago, before Mars lost its magnetic field and the sun stripped away most of its atmosphere, that world had weather. It had clouds and flowing water, and for a while, the same essential ingredients Earth had. Then the warmth left, and the water did 2 things. Some of it drifted away into space over billions of years. Molecule by molecule, But a great deal of it did something quieter and, for our settlers, far more important. It froze. And it hid. The polar caps of Mars hold enormous amounts of water ice, visible from Earth through a decent telescope, but the discovery that changes everything for a settlement is what lies buried far from the poles. In May of 2008, NASA's Phoenix lander touched down on the high northern plains, scraped a shallow trench with its robotic arm, and photographed bright white chips at the bottom. Over the following days, in image after image, those chips slowly shrank and vanished into the air, behaving exactly as exposed water ice should in that thin, dry atmosphere. It was the first time a machine had touched Martian water where it slept. In the years since, orbiting cameras have photographed something even more convincing. Fresh meteor strikes that punched through the surface and splashed clean, gleaming ice across the ground. In mid-latitudes, engineers once assumed were dry. NASA teams, mapping these buried deposits, have concluded that in some promising regions, future crews might reach ice with little more than determined digging. In places just a few feet down. So the water is real, and it is reachable. And that is the good news. Whole and unqualified. But now comes the sentence I most want you to carry out of this chapter. So let me say it slowly, the way it deserves. En masse. Water is not something you find. It is something you must industrialize, because that buried ice is not a pond waiting under a lid. It is frozen harder than concrete, at temperatures far below anything in Antarctica, cemented into the ground, and mixed through with dust and with the perchlorate salts we met 2 chapters ago, the ones toxic to the human thyroid. Reaching it means machines that can chew frozen ground. Melting it means power, a great deal of power, spent on every gallon. Cleaning it means chemistry, and filtration, and testing, every time, forever. Because a mistake is not a bad taste. It is a poisoning. Every glass of water on Mars is a small factory product, and the factory can never be allowed to stop. This is why the second half of the water story does not take place on Mars at all. It is taking place right now, tonight, a few hundred miles above your bed. Aboard the International Space Station, NASA has spent more than 2 decades perfecting a technology with none of the glamour of rockets and arguably more importance. The art of using the same water over and over. The station's recycling systems collect moisture from the crew's breath, from their sweat, and, yes, from their urine, and purify all of it back into drinking water, cleaner than most city tap water on Earth. Astronauts are fond of joking about it, and the joke conceals a triumph. In 2023, NASA announced that this closed loop had reached 98% recovery, a milestone the agency had pursued for years. Because 98% means a crew needs only a trickle of new water to live indefinitely. For a Mars settlement, that loop is not a convenience. It is the difference between mining ice as a constant, desperate chore and mining it as an occasional top-up. En masse. A family would drink the same water for years, around and around, each glass a veteran of 1,000 previous days, replenished from the frozen ground beneath the floor. And then there is food, the third pillar, and the one with the longest clock. Air can be stored for months. Water can be stored and recycled. But a settlement that intends to stay, and, as we have seen, every Mars settlement must stay, at minimum, for the 400 days the orbit's demand eventually has to grow what it eats. Here too there is genuine, sourced good news, and it is leafy and green and slightly absurd. In August of 2015, astronauts aboard the space station gathered around a small chamber called Veggie, harvested a crop of red romaine lettuce grown entirely in orbit under banks of colored light, dressed the leaves with a little oil and vinegar, and ate them, the first food ever grown and eaten in space by an American crew. They laughed while they did it, and one of them said it tasted like arugula. Meanwhile, in laboratories on Earth, researchers have grown crops in carefully prepared imitations of Martian soil, learning which plants tolerate it and what must be washed out first. The quiet lesson of all this work is hopeful. Plants are more forgiving than we feared. Give them light, warmth, water, and protection, and they will do their ancient patient work almost anywhere. But notice, one more time, the shape that every solution takes, because by now you can probably see it coming before I say it. The lettuce grows, but only inside a pressurized chamber. The soil feeds, but only after machines wash the poison from it. Or the crops are grown with no soil at all, their roots bathed in circulating water under electric light. The greenhouse must be heated through nights colder than the coldest place on Earth. And shielded from radiation, the sky is too thin to stop, which likely means burying it, growing the settlement's gardens underground, beneath the world's own rock, in rooms that glow. On Earth, a garden is the simplest thing a human being can make. A packet of seeds and a patch of dirt. On Mars, a garden is a life support system with leaves. Let your shoulders soften one more notch, because we have arrived somewhere important, and I want to gather it gently. Across these last 2 chapters, we have solved, at least in principle, air, water, and food. The 3 oldest requirements of human life all have real answers on Mars, demonstrated or nearly so, and that is a remarkable thing to be able to say. But look at what the answers have in common. The oxygen plant, the ice mine, the recycling loop, the buried greenhouse, the power station feeding all of it. Every solution is infrastructure. None of it fits in a suitcase. All of it must be landed, assembled, and kept alive for years. And infrastructure has a personality. It roots you. Every ton of machinery, every dug tunnel, every planted bed makes the settlement stronger, safer, more alive, and every single piece of it points in the same direction, toward staying. Nothing about a life support system helps you leave. A colony, by its very nature, is an anchor that a community builds around itself, willingly, one weld and one lettuce leaf at a time. Which brings us, at last, to the threshold this entire night has been approaching. Suppose the settlers want to go home. Suppose the 400 days have passed. The clockwork has come around, and the orbital door stands open. Between them and Earth now stands exactly one thing. A machine, a rocket, fueled and upright on the red sand, pointed at the sky. And the honest, extraordinary fact about that machine is that in all of human history, nothing like it has ever existed. That story is next, and it begins not on Mars, but late at night in a quiet building in California. with a handful of tubes of stone. Somewhere in Pasadena, California, tonight, there is a building at the Jet Propulsion Laboratory where the lights never entirely go out. Inside it, men and women sit at consoles through the small hours, keeping watch over machines on another planet. Machines they will never touch. Some of them have spent 20 years of their careers this way. On desks around the room sit the ordinary artifacts of American office life: family photos, coffee cups, a child's drawing taped to a monitor, and, on the screens above all of it, the weather on Mars. It is one of the strangest and most tender workplaces our species has ever created. And I want you to hold its image for a moment, because the people in that room are living, nightly, with the problem this chapter is about. Everything they have ever sent to Mars has stayed there. Every rover, every lander, every beloved machine they have named and nursed and mourned. Mars, so far, is a place things go, and do not come back from. Now, let me lay down the central fact of the entire night, plainly, the way it deserves. In all of human history, nothing has ever launched from the surface of Mars into space. Read that sentence again slowly, because it hides in plain view. We have landed many machines on Mars across 50 years, and lost many others trying. A brave little helicopter named Ingenuity has even flown above the surface, buzzing from place to place on whirring rotors through that whisper-thin air. Dozens of flights. A genuine marvel, but no object. Not a rover, not a capsule, not a single sealed tube of dust has ever fired an engine on that surface, climbed away from that gravity, and reached space. The technology for leaving Mars does not sit in a warehouse awaiting a crew. It has never been demonstrated, at any scale, by anyone. When we speak of a person riding home from Mars, we are speaking of a kind of machine that has never existed. To feel why, remember what leaving Earth requires. A thing we have done thousands of times and therefore stopped noticing. A rocket that carries humans to orbit is a skyscraper of machinery, and nearly all of it, by weight, is propellant. It stands on a launch pad that took years to build, tended by thousands of people, fed by tanker trucks, checked by armies of inspectors, watched over by control rooms full of specialists. That entire civilization of support exists to overcome one planet's gravity. Once, in the most rehearsed maneuver our species performs. Now, imagine needing all of that on Mars. There is no pad, there is no tanker truck, there is no factory that built the rocket, no crane that stacked it, no army of inspectors, and the nearest engineer, who is not already part of the crew, is, at closest approach, 35 million miles away. And above all, there is the propellant problem. And here the story turns almost poetic in its difficulty. You cannot simply bring the fuel for the trip home with you. We heard the number earlier tonight. A crude ascent from Mars would demand something like 25 to 30 metric tons of liquid oxygen alone, before counting the fuel it burns with. Hauling that from Earth means landing it on Mars. And landing anything heavy on Mars is itself one of the hardest maneuvers in spaceflight. And every ton of return propellant demands many further tons of propellant just to deliver it. The arithmetic feeds on itself. Carried fuel is a snake eating its own tail. So the serious plans do not carry the fuel. They make it there. And the method has a lovely simplicity at its heart. Engineers call it in situ resource utilization, living off the land. And for Mars it works like this. The air, as we know, is carbon dioxide. The ground, as we know, holds water ice. Split the water and you have hydrogen and oxygen. Combine the hydrogen with the carbon from the air. Using a chemical reaction discovered more than a century ago, and you can manufacture methane, an excellent rocket fuel, along with more oxygen to burn it with. Air plus ice plus power equals propellant. A factory on Mars, running quietly for a year or two before any crew even arrives, could in principle fill the tanks of a return rocket entirely from Martian materials. This is not a fringe idea. It is the published backbone of SpaceX's entire Mars architecture. And NASA's studies lean on versions of it too. On paper, it is the key that unlocks the door home. But the promise of tonight is to weigh whole truths. So let us hold the key up to the light and see what it actually asks. It asks that a chemical plant be landed on Mars intact, along with a power station large enough to run it. Most designs assume a small nuclear reactor or fields of solar panels, plus the mining machines to feed it ice. It asks that this entire industrial ecosystem then operate automatically, in the cold and the dust and the radiation, for upwards of a year, with no technician able to arrive in under half a year if a single valve sticks. It asks that the return rocket itself stand through that same year of dust storms and 100-degree temperature swings with its systems and its slowly filling tanks intact. And it asks that all of it work, essentially perfectly, the first time it is ever truly tested end to end, because the test is the crew's ride home. If that sounds like an extraordinary chain of things that must all go right, here is the honest yardstick for measuring it. And it is the story those night shift engineers in Pasadena know best of all. For years, NASA and the European Space Agency have been planning a mission called Mars Sample Return. Its goal is thousands of times more modest than bringing home a person. It aims to retrieve a few dozen small sealed tubes of rock and soil. Tubes the Perseverance rover has already filled and left waiting on the ground at Jezero. Just the tubes. A payload you could carry in a backpack. Achieving even that requires designing the first rocket ever intended to launch from Mars. A slender machine called the Mars Ascent Vehicle. Small enough to ride to Mars, folded inside a lander. Just powerful enough to loft its little cargo to orbit. And that modest plan has strained two of the wealthiest space agencies on Earth. In September of 2023, an independent review board examined the program and delivered sobering news, estimating its cost had grown to between $8 and $11 billion, and warning that the samples might not reach Earth until around 2040. The following year, NASA publicly asked the American aerospace industry for cheaper, faster ideas to rescue the effort. All of that for a backpack of stones. Now, scale the picture up, gently, in your mind, from a payload of tubes to a payload of living human beings, with their cabin, their air, their water, their food, their radiation shelter, everything needed to keep them alive for the 9-month crossing home. From a rocket the size of a telephone pole to a vehicle with the muscle of the machines that leave Earth. From tanks filled on Earth to tanks filled by a robot factory from Martian sky and Martian ice. Nothing in that picture is proven impossible. And I want to say so clearly, because brilliant and serious people are working on every piece of it tonight, and they may well succeed in the decades ahead. But nothing in that picture has ever been demonstrated either, and that asymmetry is the quiet heart of our whole story. Every element of going to Mars, the launch, the crossing, the landing, has been rehearsed for 50 years. Almost every element of leaving Mars exists tonight, only as engineering on paper. So here is the third of our 4 doors, seen now in full. The door made of machinery. The ride home is not waiting on Mars. It must be built, fueled, and proven there by systems that have never yet flown. And until they do, every landing on Mars is, in the plainest engineering terms, a one-way trip that hopes to become otherwise. Let a long breath go here, all the way out, because the hardest chapter of the night is behind you now. And notice what stands beside the unbuilt rocket, patient as ever. Suppose the factory hums, the tanks fill, the ascent vehicle waits gleaming on the sand. There remains a question no machine can answer, and it rides home inside the traveler's own chest. After years under Martian gravity, is this body still capable of the journey and of the heavy blue planet waiting at its end? That question is next. And it folds our whole story back upon itself in a way I find quietly haunting. Imagine, just for the length of this chapter, that everything goes right. The factory ran without failing through the long Martian year. The tanks filled, gram by gram, from sky and ice. The ascent vehicle stood through the dust storms, and the orbital clockwork has come around at last, and the door made of orbits stands open. After years on Mars, a settler climbs the ladder, straps into a seat pointed at the butterscotch sky, and prepares, finally, to go home. This chapter is about the quiet possibility that even now, with every machine ready, the settler's own body may not be. And because this is exactly the kind of subject where a storyteller could frighten you instead of informing you, I am going to build it carefully, marking at every step where solid knowledge ends and reasonable concern begins. Honesty, remember, was the first promise of tonight, and this chapter is where it earns its keep. Start with what is known beyond dispute. Because we watched it earlier this evening, we know that in weightlessness, the human body dismantles what it is not using. Bone density falling 1% or more each month, measured across decades of space station medicine, muscles fading, the heart easing off, fluids drifting upward and pressing on the eyes. And we know that after mere months of this, returning astronauts meet Earth's gravity like a wall. This is not speculation. It happens on our own planet several times a year. In the grasslands of Kazakhstan and off the coasts of Florida, wherever the capsules come down, watch any landing broadcast and you will see it. The hatch opens, and the astronauts do not climb out. They are lifted out by teams of strong, gentle hands and set carefully into reclining chairs, where they sit smiling and waving and visibly unable to do much more. Their own blood, suddenly heavy, pools toward their legs and leaves them light-headed. Muscles that floated for 6 months tremble under the simple duty of sitting upright. Some manage careful steps within hours. Others need days. And full recovery, the kind measured in bone, takes months of supervised rehabilitation with the entire medical infrastructure of Earth standing by. That is the price of 6 months in the void, paid at the door of the gentlest possible homecoming. Now build the settler's homecoming on top of that solid knowledge, one layer at a time, and watch where it leads. The first layer is the years on Mars themselves. We named the 2 possibilities in the chapter about gravity, and named them honestly as open questions. If Martian gravity, at 38%, turns out to be enough to hold the body steady, this layer costs little. But if the concerning possibility holds, if the body reads Mars as merely a slower version of weightlessness, then a settler of 5 or 10 years has been quietly renovated, bones lightened toward Martian sufficiency, heart eased into a gentler workload, a frame comfortably and thoroughly at home in a world that pulls with barely a third of Earth's insistence. The second layer is the crossing itself. The ride home is another 6 to 9 months, and it is spent in full weightlessness. The harshest environment the body knows, subtracting still more bone and muscle at the worst conceivable moment. The way a long illness weakens a patient in the very weeks before a major surgery. And the third layer is the destination, Earth, full, permanent, 100% Earth, which does not greet returning travelers gradually. It arrives all at once. In the fire and deceleration of re-entry, forces that press a healthy astronaut deep into their seat. And then it never lets go again. For the settler descending that final ladder, every step, every stair, every night of sleep and morning of rising, for the rest of their life, happens under nearly triple the gravity their body has known for a decade. Assemble the 3 layers, and you can see why medical researchers who study long-duration spaceflight have raised a concern that goes beyond difficulty into genuine danger. A skeleton adapted downward through Martian years and further thinned by the crossing might meet Earth's pull with bones measurably more vulnerable to fracture, so that a stumble on a staircase carries the threat a fall carries for the very old. A heart accustomed to lighter work might strain against blood that has suddenly, permanently gained weight. Now the boundary line, drawn clearly, as promised. No returning Mars settler has ever existed. So this outcome has never been observed in a human being. And it is a projection built by reasoning outward from measured facts. A concern that serious scientists take seriously. Not a certainty. It might prove milder than feared. Countermeasures. Hard exercise. Medication. Perhaps spinning sections of future ships to simulate gravity on the way home. Might soften it substantially. All of that is possible. And fairness requires saying so. But now, step back and look at the shape of the thing. Because the shape is the point. And it is the strangest, saddest, most beautiful idea of the entire night. Let it come slowly, with an unhurried breath. Earlier this evening, we watched Mars begin remaking the settler's body from the very first week. Lighter bones, an easier heartbeat, a frame settling, gram by gram, into the gentle grip of a smaller world. And notice what those changes actually are. They are acts of belonging. They are the body doing what bodies have always done for wandering humans. On every continent and at every altitude our species has ever settled, quietly reshaping itself to make a strange place home. the settler's body is not fishing on Mars. It is succeeding. It is putting down roots in the only way a body can, and every one of those same changes is, at the very same time, a quiet severing. The better the body fits Mars, the worse it fits Earth. Belonging to the new world and remaining able to return to the old one may be, at the level of bone and blood, the same coin facing opposite ways. Nobody decides this. No door slams. The door of the body closes at the speed of adaptation, one heartbeat at a time, and the settler grows into their new home and out of their old one in the same silent motion. On Mars, time itself takes a side, and it sides with staying. So now, at last, all four doors of our story stand where we can see them together. The door of orbits, swinging on its 26-month clockwork. The door of the body, closing at the speed of adaptation. The door of machinery, waiting to be built by hands that have never built it. And one final door remains, the least dramatic and perhaps the most decisive of all, made not of physics or biology, but of budgets, of cargo lists, of the patient unsentimental arithmetic of who pays for what and why. That ledger is soon to open, but not quite yet. Because we have been speaking for a long while now of bones and rockets and tons of oxygen, and it would be easy to forget that at the center of every number tonight there is a person who, on some future evening, after the machines are checked and the airlock is sealed, will stand at a small window in the last light and look up and find, low over the western hills, a steady blue-white star that does not twinkle. Everyone they have ever loved is on it. What that view does to a human heart, not the muscle this time, but the other thing we mean by the word, is where our story goes now. It is the gentlest chapter of the night, and you have earned it. There are no rockets in this chapter, and no tons of anything. This chapter is about the oldest technology human beings possess, the sound of a voice we love, and about what happens to that voice when it must cross 50 million miles of vacuum to reach us. Begin at the window. It is evening on Mars. The wind has settled. The small, pale sun has gone down behind the western rim of the crater, and the sky is doing its nightly performance in reverse. Glowing rose and amber overhead, while the horizon around the vanished sun cools to a quiet, luminous blue. Our settler stands at the habitat's little window with a cup of something warm, recycled water, greenhouse mint, and looks up, and there, hanging low in the deepening color, is a star that is not a star. It is brilliant, and steady, and ever so faintly blue, the brightest thing in the sky. It is Earth, every city that has ever existed, every ocean, every forest, every song, every person the settler has ever loved or lost. All of it is contained in that single point of light, small enough to be hidden behind a thumb held at arm's length. Humanity has already seen this exact view, and the seeing has a history worth telling softly. In January of 2014, the Curiosity rover paused its work after sunset, raised its camera mast, and photographed the Martian twilight. In the frame, above the darkened hills, hangs one bright point, with a fainter speck beside it. The point is Earth. The speck is our moon. NASA published the picture with a caption noting that a person standing on Mars could see them both with the naked eye. An evening star like any other, except that it is everyone. And that photograph itself has an ancestor. In February of 1990, at the urging of the astronomer Carl Sagan, NASA commanded the departing Voyager 1 spacecraft, already beyond the planets, to turn its camera back and take one final picture of home. In it, Earth is less than a single pixel, a pale blue mote suspended in a shaft of scattered sunlight. Sagan spent years reflecting on that image, on how everything we are had been gathered into a point, and his reflections became some of the most beloved words ever written about our planet. The settler at the window lives inside those reflections now. For them, the pale blue dot is not philosophy. It is the view from the kitchen, and the view comes with a rule we met early tonight and must now feel in full light. And, therefore, every radio message, every voice, every video takes between about 3 and 22 minutes to cross from Mars to Earth, depending on where the two planets ride on their tracks. This is not a limitation of our equipment, to be engineered away by some cleverer antenna. It is the speed limit of the universe itself. So when the settler at the window records a message, a simple one, "I miss you, tell me everything," and sends it, those words fly through the dark for up to 22 minutes before any ear can hear them. And the reply, a mother's voice, a brother's laugh, a child reciting her day, spends its own long minutes flying back, the shortest possible exchange, one sentence each way, can take most of an hour, a real conversation, the kind with interruptions and laughter and talking over each other, is not delayed by the distance. It is abolished by it. Sit with what quietly disappears inside that fact. Not communication. Communication survives, abundant and rich. What disappears is simultaneity, the experience of sharing a moment as it happens. No video call where a father watches his daughter's face change in the instant she hears his news. No phoning home in a frightened hour to hear, right now, tonight, that everything will be all right. Every exchange with Earth becomes, in its deepest structure, a letter, spoken aloud perhaps, recorded in moving pictures perhaps, but a letter all the same, composed alone, sent into silence, and answered in silence. In this one specific way, a settler on Mars lives farther from home than any sailor of any past century, because even the loneliest sailor, once ashore, could stand in a doorway and hold a conversation. On Mars, the delay never comes ashore. Can human beings actually bear this? It is a fair question, and remarkably, we have real evidence, because researchers have rehearsed this exact life on Earth, deliberately, more than once, between 2010 and 2011, in a windowless facility in Moscow, an experiment called Mars 500 sealed 6 volunteers from Russia, Europe, and China inside a MOXIE spacecraft for 520 days, the full length of a Mars mission, complete with an artificial communication delay to the outside world that grew and shrank to match a real voyage. NASA has funded similar rehearsals, including a program in Hawaii called High Seas, where small crews lived in a white geodesic dome on the red slopes of the Mauna Loa volcano, terrain chosen for its resemblance to Mars. Stepping outside, only in mock spacesuits, speaking to everyone they loved through a mandatory 20-minute delay, in one mission for a full year. And the findings from these sealed worlds were, in a way, both comforting and cautionary. And you deserve both halves. The comfort is that the crews endured. Nobody broke. The missions completed. Human beings, the researchers found again and again, are astonishingly good at adapting to almost anything. The caution lives in the details of the published studies. Some crew members drifted into disturbed sleep, their days unmoored. Some withdrew, growing quieter month by month, choosing the delay's silence over its awkward half-conversations. The psychologists watching concluded that the true challenge of a Mars voyage is unlikely to be a single dramatic crisis. It is a long, slow weathering, the gradual erosion of connection, one delayed message at a time. And the crews that fared best were the ones who built rituals, meals, celebrations, small ceremonies, and defended them fiercely. Remember that finding it returns warmly near the end of tonight. There is one more concern, subtle and strangely moving, and researchers who study spaceflight psychology speak of it carefully. Every astronaut who has ever flown, even those who spent a year in orbit, has been able to drift to a window and see Earth. Enormous, bright, blue, unmistakably home, filling the view. Psychologists have coined a name for what its absence might do. They call it the Earth out of view phenomenon. The untested question of what happens in a human mind when the home planet shrinks to just another light among the lights. It has never happened to anyone in all of history. It would happen to every Mars traveler within weeks of departure. And it would never, for a settler, be undone. The honest words here are the careful ones. Nobody knows what that costs. The people whose job is to know think it is worth worrying about. And they are watching for it. Let your breathing lengthen here, in the quiet, after all that silence. Because I want to close this chapter with its own strange comfort. And it is a real one. In every sealed rehearsal, in Moscow and on the volcano, when the hatches finally opened and the crews walked out into the sun, reporters asked them the same question. Do you regret it? And, across the studies, the answer that came back, again and again, was no. Many said they would do it again. Some said the year inside was among the most meaningful of their lives. Whatever the silence takes from people, it seems, there are human beings from whom it does not take the thing that matters most. Hold that gently. It is a lantern we will need for the last hour of tonight. But first, one door remains, the fourth and final one, and it is the least romantic thing in this entire story. It is a spreadsheet, and what that spreadsheet says about the ride home, about who would pay for it, and what the same money could buy instead, may be the quietest and most decisive reason of all that the first settlers stay. Numbers, at this hour of the night, can be surprisingly restful. Let us open the ledger. Every great journey in human history has had two stories. There is the story told around the fire afterward, of courage, storms, and new horizons. And there is the story written in the ledger, of what it cost, and who paid, and what they believed they were paying for. Tonight we have honored the fire story for hours. Now, gently, in the softest chapter of numbers you will ever hear. Let us open the ledger. Because inside it is a reason for staying on Mars that has nothing to do with orbits or bones. And it may outlast all the others. Start with the only entry humanity has ever actually written in this particular ledger. The only time we have paid the full price of putting people on another world. The Apollo program landed 12 Americans on the moon between 1969 and 1972, and it cost the United States about $25 billion in the money of that era, adjusted into today's dollars. Analyses, such as those published by the Planetary Society, put the true figure at more than $250 billion, $250 billion. At its height, the effort consumed more than 4% of the entire federal budget of the United States and employed around 400,000 people, an army of engineers, seamstresses, sewing, spacesuits, mathematicians, welders, an entire hidden city of effort, and all of it bought visits. A dozen people, a few days each, on a world 3 days from home, Mars. As we now know deep in our bones tonight, is not 3 days from home. It is 6 to 9 months away, with a mandatory surface stay of more than a year, a round trip of nearly 3 years, door to door, and the one time the American government asked, formally and seriously, what such a journey would cost. The answer arrived like a closing door of its own. In July of 1989, on the 20th anniversary of the first moon landing, President George H.W. Bush stood on the steps of the National Air and Space Museum and called for Americans to return to the moon and then travel on to Mars. NASA studied the proposal and reported back a price in the neighborhood of $450 billion. In the money of that day, Congress read the number, and the initiative quietly, politely, died. Not because anyone doubted the destination was reachable. The ledger, not the physics, said no, now, fairness to the present. Because the ledger is genuinely being rewritten as you drift here tonight. Over the past decade, reusable rockets, pioneered above all by SpaceX, have cut the cost of lifting cargo to space dramatically. Boosters landing upright on ships at sea and flying again, a sight that would have seemed like fantasy to the engineers of Apollo. The company's founder has said openly, for years, that the entire purpose of the enterprise is to drive costs down far enough to make a self-sustaining settlement on Mars possible. Costs may keep falling, perhaps enormously. Honest analysis grants that gladly, and tonight does. But here is the point of this chapter, and it is built to survive every optimistic assumption about cheaper rockets, so let it settle slowly, like the last coin dropped into a jar. However low the ledger's numbers fall, a returning mission always costs several times more than a staying mission. Not slightly more, several times. And you already know every reason why. Because you have spent tonight learning them. Think of what a one-way cargo list looks like. Habitats, greenhouses, ice miners, the oxygen plant, power stations, food and spare parts. Every ton of it lands on Mars and immediately begins working, and keeps working, compounding, for years. Now think of what the return ticket adds to the manifest. The ascent rocket itself, the largest single machine of the entire mission, which must be landed intact and then stand idle for years, doing nothing but waiting. the propellant factory to fill it, with its own dedicated power plant, the extra mining fleet to feed that factory, spares for all of it. And then, beyond all of that, the ride for the 9-month crossing home, a habitat ship with life support, food, water, and radiation shelter for the whole crew, launched, flown, and maintained across years, for a single use. Mission planners who assemble these architectures find, consistently, that the return portion dominates the mass and the money of everything. In the plainest terms, for the price of bringing one small crew home, a sponsor could land several more crews, or years of supplies, or the beginnings of an entire second settlement. And if that trade still feels abstract, the ledger has one painfully concrete recent page, and we have already read part of it tonight. Mars sample return, the joint effort of NASA and the European Space Agency to retrieve a backpack's worth of sealed rock tubes. No crew, no life support, no one's safety aboard, was priced by its own independent review board in 2023 at $8 to $11 billion, with samples possibly not home until around 2040. Whatever a human return ticket ultimately costs, that number is its distant, far smaller cousin, and it was large enough to send an entire space agency searching for rescue plans. So, we arrive at the quietest question in the whole ledger, the one that, in the end, decides everything. And it is not an engineering question at all. Who pays for the ride home? And why would they? Follow the money's own logic for a moment, without cynicism, just clear eyes. A settlement sponsors, whether a government, a company, or a coalition of both, are buying things with every launch. They are buying science, and capability, and prestige, and the sheer historic fact of a human presence on another world. Now, a return flight is not worthless to them, and honesty requires the full accounting. A crew coming home brings priceless medical knowledge, the first data ever gathered on what years of Mars do to a human body. It brings samples, experience, heroes for the evening news, and the simple, immeasurable good of families reunited. All of that is real value, but set it in the ledger beside the alternative. Because budgets are nothing but choices between alternatives. Every dollar spent on the ride home is a dollar not spent on another habitat, another greenhouse, another crew, another year of safety margin for the people already there. The return ticket adds less directly to the settlement's survival than almost any other line on the manifest. And so, in budget review after budget review, year after year, it is the line most vulnerable to a pencil, not cancelled with any cruelty, simply deferred to the next window, and then to the next, by sponsors whose mission was always the settlement itself, while the settlement, as we have seen all night, grows more rooted, more invested, and more permanent with every passing month. Breathe out, long and unhurried, because the ledger is closed now, and with it, something larger. This was the fourth door, and notice how different its material is from the others. The door of orbits is celestial clockwork, older than life. The door of the body is biology, written in bone. The door of machinery is steel that has not yet been forged. And this one is only paper, columns of patient figures. The most human door of all. and it leans on the same side of the same threshold as all the rest. Unlike the others, this door was never hidden on Mars. It was visible from Earth all along, printed in the architecture of every serious settlement plan ever drafted, legible to anyone who cared to read it. 4 doors. Then, and we have now stood before every one. In the next chapter, we will step back at last and look at all 4 together, in a single view, calmly and honestly, because you have been patient all night and you have earned the complete answer to the question in our title. And I will tell you now, softly, what you may already sense. The answer is not a tragedy. It never was. What it is, instead, we are about to see. Every long night of thinking deserves one moment when everything is laid out in a single view. Nothing hidden, nothing rushed. This is that moment. So make yourself a little heavier in the bed. Let the pillow take the full weight of your head. And look with me, one last, unhurried time, at the 4 doors between a Mars settler and home. The first door is made of clockwork. Earth and Mars are 2 runners on 2 nested tracks, and the crossing between them is affordable only when their positions align. A window a few weeks wide that opens roughly once every 26 months. Whoever lands on Mars watches that door swing shut behind them and faces a wait of 400 days or more before it can open again. Not by anyone's decision, but by the geometry a quiet civil engineer named Walter Hohmann worked out in his evenings a century ago. This door is the gentlest of the 4 because it, at least, reliably reopens, but it sets the tempo for everything else. On Mars, leaving is never a choice you make today. It is an appointment you keep in 2 years. If, and only if, everything else allows. The second door is made of the traveler's own body, and we watched it close in slow motion, bone thinning at 1% or more each month in weightlessness, measured across decades of station medicine and confirmed in the year-long flight of Scott Kelly while his twin brother waited on the ground. An invisible sleet of galactic radiation, recorded by the instrument that rode to Mars inside the Curiosity mission, spending most of a career's permitted exposure on a single round trip. And, beneath both, the great open question of 38% gravity, a condition no human being has experienced for longer than 3 days, quietly remaking every settler for a lighter world. Medical researchers have raised the sober concern, and it remains a concern rather than a proven fact, that a body thoroughly adapted to Martian years might find Earth's full pull not merely exhausting, but hazardous. This door closes at the speed of adaptation, and the longer the stay, the heavier it grows. The third door is made of machinery that does not yet exist. Nothing in human history has ever launched from the surface of Mars into space. The ride home requires an ascent rocket that has never been built, fueled by a propellant factory that has never been assembled, standing on ground where no launch has ever occurred. All of it working, unattended. The first time it counts. And the honest measure of that challenge is the struggle of Mars sample return. The effort just to lift a backpack of sealed stones off that surface, priced by its independent reviewers in 2023 at $8 to $11 billion and slipping toward 2040, not impossible, simply, and by a wide margin, the least proven part of the entire journey. And the fourth door is made of arithmetic. Every serious mission architecture shows the same lean, The return portion, the idle rocket, the fuel plant, the crossing ship maintained for years for a single use, dominates the cost of everything, while adding less directly to the settlement's survival than almost any other cargo. And so, in budget meeting after budget meeting, on a project measured in decades, the ride home remains the line most easily deferred. Window after window, by sponsors whose mission was always the settlement itself. Now, here is the honest heart of it. The sentence I most want you to carry out of this chapter and into your sleep. Not one of these 4 doors is locked. Say it again, slowly, inwardly. Not one is locked. The clockwork door reopens every 26 months without fail, as dependable as any tide. The door of the body might be held open by exercise, by medicine, by ships that spin to make their own gravity. Ideas, engineers, sketch and argue about tonight. The door of machinery could be opened by a decade or 2 of determined engineering. And determined people are engineering it right now. Even the door of arithmetic could be opened by simple abundance. If launch costs keep falling the way this past decade has actually seen them fall, any single door, alone, could plausibly be opened. That was never the problem. The problem, the quiet consensus that emerges when engineers and doctors and mission planners are asked to speak honestly and together, is that all 4 doors must stand open at once, aligned like the tumblers of a single lock. The window must be open, and the rocket must be fueled and proven, and the budget must have survived years of reviews, and the settler's own body must still be equal to the crossing and to the heavy planet waiting at its end. Each of those, alone, is uncertain. Their conjunction, for the first generation of settlers, with the technology of our own era, is why so many people who study this seriously arrive at the conclusion our title states plainly. The first people who go should expect and plan never to come back. And let me set that sentence down with the care it deserves, because it carries our whole night. That does not mean return is impossible forever. It means that permanent settlement is the more honest assumption for the early missions, and the wiser plan, and that anyone who boards the ship should board it as an emigrant, not as a tourist. In time, decades perhaps, the doors may be propped open one by one, the rockets proven, the medicine learned, the costs tamed, and traffic may someday flow both ways across Hohmann's old arcs. The first settlers themselves may live to see it, but they cannot plan on it, and the honest ones will not. And there, breathe easy now. The night's hard work is truly done. Because notice what that last paragraph quietly did. It changed the kind of story we are in. If the one-way nature of the first voyages were a trap, something discovered too late by innocent travelers, tonight would be a tragedy. And I could not have told it to you as a bedtime story. But it is not a trap. It is the most clearly labelled door in the history of exploration, studied for decades before anyone walks through it, printed, in effect, on the ticket itself, which leaves us, for the rest of tonight, with the truly astonishing fact, the warm and human fact that all 4 doors together cannot explain away. Knowing everything you now know, every orbit, every gram of bone, every billion in the ledger, thousands upon thousands of people have already read that ticket carefully, understood it completely, and said yes. Who are they? What do they see that a spreadsheet cannot? To find out, we are not going to look up at Mars at all. We are going to look back at the harbors and docksides of Earth's own past. At candle-lit farewell parties in Irish cottages and crowded rails of ships leaving Liverpool and Naples and Southampton. Because this exact choice, it turns out, is one our own families have made before. Many of you listening tonight exist because somebody made it. That story, the human half of the night, begins now, and from here to the end. I promise. The road runs gently downhill, towards sleep. In 2012, a small company in the Netherlands made an announcement that sounded like science fiction, and, as it turned out, largely was. The company was called Mars One, founded by a Dutch entrepreneur named Bas Lansdorp, and its plan was breathtaking in its simplicity. It would send volunteers to Mars beginning in the 2020s, fund the venture partly as a global television event, and this was the headline that circled the world. The tickets would be one way, no return vehicle, no return plan, permanent relocation to another planet. Stated plainly on the label, for anyone willing to sign, honesty first. As always, as an engineering and business project, Mars One failed, and it deserves to be described without softening. Independent experts began finding serious problems almost immediately. In 2014, a widely reported study by researchers at the Massachusetts Institute of Technology analyzed the plan's life support and supply assumptions and concluded that, as designed, the settlers would face fatal shortfalls. The funding never truly materialized. The timeline slipped and slipped again, and in January of 2019, the venture collapsed into bankruptcy, having launched nothing at all. Mars One belongs today on history's long shelf of schemes that promised more than they could build. But tonight, Mars One matters for a completely different reason. 1. Its bankruptcy never touched. It matters because of what happened when the application window opened, because the company had asked. In effect, a pure question, stripped of every disguise and every safety net that softens the same question in agency brochures. Who will leave Earth forever, knowing fully that it is forever? And people answered. The company itself claimed enormous numbers of applicants, and journalists later disputed those claims. So let us stand only on the verified ground. Even by the most skeptical independent counts, thousands of people completed serious applications, paid their fees, recorded their video pleas, and advanced through rounds of interviews. For a one-way ticket to a lethal desert, they were teachers, physicists, nurses, students, taxi drivers, grandparents. And when reporters sat across from the finalists and asked the only question that matters, do you truly understand that you would never come home, never again stand in the same room as your mother, your brother, your oldest friend? The answers that came back were not naive, and they were not deranged. They were calm, considered, and strangely moving. Yes, they said, we understand. We have thought about little else. And the answer is still yes. If that seems incomprehensible to you, lying warm in your bed tonight, I want to suggest, gently, that it seems so only because we have forgotten our own story. Because the one-way ticket is not an invention of the space age. It is one of the oldest and most ordinary objects in human history. And for a great many of you listening tonight, in America especially, it is quite simply the reason you exist. Consider the crossing that founded the country most of you are sleeping in. When English families boarded the Mayflower in September of 1620, the voyage to the New World took about 2 months of storms, sickness, and salt beef, and for ordinary passengers, farm families, servant, the young, there was no realistic prospect of ever making the crossing twice. The Atlantic, for them, was as absolute a barrier as the gulf between planets is for us. Letters home took months, when they arrived at all, carried by ships that sailed twice a year. Parents embraced grown children on the dock at Plymouth or Rotterdam and understood, both sides understood, that this was almost certainly the last touch of that hand in this life. And they boarded anyway. And then, across the following 3 centuries, millions more boarded behind them. Through the 1800s and into the early 20th century, tens of millions of Europeans, Irish families fleeing the famine, Italians and Poles and Norwegians and Greeks seeking land and bread and futures, crowded the rails of emigrant ships out of Liverpool and Naples and Hamburg, bound for New York and Boston and Baltimore. Historians note, fairly, that in the later age of fast steamships, a real number of emigrants did eventually return home. But for vast numbers, especially the earliest and the poorest, emigration meant permanent goodbye, and everyone involved knew it at the dock. The people of Ireland, who understood this as deeply as anyone on earth, gave the knowledge a name, and it may be the most quietly devastating phrase in the English language. On the night before an emigrant left for America, the family and the whole village would gather in the cottage for music, dancing, drink, and weeping, a farewell celebration that lasted until the departure at dawn. They called it an American wake. A wake, the vigil the Irish kept for their dead, held instead for a living person, because the family understood, with complete clarity, that the departing son or daughter, though breathing, though laughing at the center of the room that very night, was passing beyond reach for the rest of their lives. The living were mourned because the leaving was real, and in the morning they left anyway, carrying a bundle and an address in Boston, and the ones who stayed watched the road until the cart was out of sight. Hold that candlelit room in your mind for a moment. The fiddle music, the mother memorizing her son's face, because that room is the most honest mirror our history offers for the choice a Mars settler makes. Not an astronaut's tour of duty, which ends in splashdown and a parade. An emigrant's departure, which ends in a new life, and was chosen anyway. Eyes fully open, by ordinary people, in their millions, generation after generation, seen from that cottage doorway. The one-way ticket is not an aberration in the human story. It very nearly is the human story. Our species walked out of Africa on one-way journeys. Polynesian navigators pushed canoes into the open Pacific toward islands they could not see and could not prove existed. The wagon trains rolling west out of Missouri in the 1840s were, for most families aboard, permanent departures from everyone they knew. There was rarely a return baked into any of it. There was only forward, and the stubborn, sometimes unreasonable human conviction that forward was worth everything it cost. Now, the promise of this channel cuts both ways. So let me mark the limits of the mirror plainly. The emigrants of the past sailed toward places with air they could breathe, water they could drink, and soil that would take a seed. And no courage in any Irish cottage changes the physics we have spent tonight learning. Mars is not simply another Atlantic, and it would be false comfort to say so. The crossing is harsher, the shore is deadlier, and the technology of survival, as we have seen, is still being invented. And yet, when psychologists study the modern volunteers and historians study the old ship manifests, they keep finding the same underlying shape in both. People do not choose one-way journeys because they misunderstand the cost. The Mars one finalists could recite the cost from memory. The family singing at an American wake understood the cost better than anyone who has ever lived. People choose, and have always chosen, because for some human beings, in every generation, the chance to begin something wholly new outweighs everything that must be left behind to begin it. Not for everyone, never for everyone, but always, reliably, for enough, so when the settlers finally go, they will go as emigrants, not as tourists, and they will have read every word on the ticket, which opens, at last, the warm final questions of our night, the ones worth carrying into sleep. What will their days actually feel like under that butterscotch sky? In the world, the four doors enclose. What happens on the evening? Someday, when the first child looks up at the blue star and learns what it is, and what, in the end, does the word home come to mean? When it rises after sunset and sets before dawn, those questions are the last hour of tonight, and they are the gentlest. The hard doors are all behind us now. Let your eyes rest, and come meet the neighbors. Before we meet the child, I promised you, hours ago now, let us spend a little while inside an ordinary day on Mars, because the texture of that day is the world the child will be born into, and its first fact is a small miracle of coincidence that almost nobody knows. A day on Mars is almost exactly as long as yours. Not roughly, almost exactly. The planet turns once every 24 hours and 39 minutes. A length so close to Earth's that scientists gave the Martian day its own affectionate name, a Sol. Of all the worlds we know, in this solar system and beyond, none matches Earth's rhythm so nearly, and the coincidence is more than trivia, because human bodies run on inner clocks tuned across millions of years to a roughly 24-hour beat. On Mars, uniquely, that ancient clock nearly fits. Settlers would wake, work, tear, and sleep to a rhythm their cells already know. We have even rehearsed it. Whenever a new rover lands, the engineers and scientists at the Jet Propulsion Laboratory live on Mars time for the first months of the mission. Their shifts, sliding 39 minutes later each day to stay synchronized with their machine's mornings. They describe it as a strange, dreamlike jet lag, dinner drifting toward midnight, then toward dawn. Families back home, slipping out of sync. Some of them wear 2 watches. For them, it is a temporary oddity of the job. For the settlers, and for the child, it will simply be time, the only time there is. But when a settler steps to the window at night, the familiarity ends, because there are 2 moons in that sky, and neither behaves the way a moon should. The larger one is called Phobos, A dark, lumpy little world about 17 miles across at its widest. And it orbits so low and so fast that it does what no other moon in the solar system does. It rises in the west, hurries across the entire sky in a little over 4 hours, and sets in the east, sometimes managing the whole performance twice in a single night, running backward against the stars. The smaller moon, Deimos, is barely more than a bright, patient spark, taking days to drift across the sky. No tides follow them. No month is measured by them. They are simply there, hurrying and loitering, the night's two odd companions. And if the settler watches the sun go down behind the crater rim, they see the loveliest reversal of all. 1. The Curiosity rover, photographed in April of 2015 and sent home to us. Sunsets on Mars are blue. The fine dust, hanging in that thin air, scatters light in the opposite manner of our sky. So the Martian day is butterscotch and pink, and the last glow around the setting sun is a cool, quiet, glacial blue. Evening on Mars looks like an Earth morning saying goodbye. Now, into one of those blue evenings, in some year no one can yet name, comes the moment this whole night has been walking toward. Somewhere in a warm lit room, buried under yards of Martian soil for shielding, with machines breathing steadily in the walls, a child is born who has never seen Earth. No such child exists tonight, and the science of human development in partial gravity remains one of the great unknowns, studied so far only in cells and small animals. So everything we say now will be said carefully, in the conditional voice this channel promised you, and I will keep that promise to the end. But some things about that child we can already say with confidence, because they are not medical questions at all. They are questions of experience. An experience we can imagine honestly. That child would learn to walk in 38% gravity, and falling would be a gentler teacher than it ever was for you. That child would grow up knowing exactly two kinds of weather, dust and clear. Rain would be a word in the old stories, like dragons. An ocean would be a picture on a screen, implausibly, extravagantly blue. The sound of wind in trees, the smell of soil after a summer storm, the feeling of walking out a door with bare skin under an open sky, all of it would belong to the mythology of the grandparents' planet, told at bedtime in rooms beneath the rock. And on clear evenings, if the dust was low, a parent might lift that child up to the little window and point to the west, just above where the blue glow of sunset was fading, at a steady, lovely, blue-white star, the brightest thing in the sky, and say the strangest sentence any parent has ever said. That is where we are from. We know exactly what that star looks like, because we already have the photograph. It is the one Curiosity took in January of 2014. Earth as the evening star of Mars, with the moon a faint companion beside it. The picture you can find tonight on NASA's website. The child's window view exists decades before the child. And the medical questions, the deep ones, deserve the same clean honesty we have practiced all night. So here it is. Researchers who study reproduction and development in space say plainly that no one knows what a childhood under Martian gravity would build. A body grown from the first cell in a lighter world might, and the word is might, develop a lighter frame, a differently proportioned heart, bones entirely sufficient for Mars and perhaps never sufficient for Earth. If that possibility proves true, then something quietly profound follows, and it is worth receiving slowly, with a long, unhurried breath. For that child, the title of tonight's video would not describe a hardship at all. It would simply describe reality, the way gravity itself describes reality. The child would not be trapped on Mars any more than you, tonight, are trapped on Earth. Mars would just be home, the only one their body has ever answered to. And Earth would be the beautiful blue star where the old stories happened. And there, feel it, the whole meaning of our night turns over, gently, like a key in a lock, because for that child, every door we have studied stands the other way around. Earth becomes the planet you may never visit. Earth becomes the world of crushing gravity, of chaotic, violent weather, of that unimaginable open sky with no dome over it at all. Somewhere on that blue star, the child knows. There are cousins who have never once checked a suit seal, who stand out in the rain on purpose, and who could likely never come here, for all the same four-door reasons. Running in reverse, the one-way door, it turns out, always had two sides. It only ever depended on where you were standing when it closed. So hold the two of them together in your softening mind, the way the window holds them, the settler who chose the crossing and still remembers rain, and the child on their arm who chose nothing, misses nothing, and is simply, completely home. Between those two people, the emigrant and the native, lies the very last question of our night, the oldest question there is, the one every wanderer in history has had to answer in their own way. What does the word home actually mean when it hangs in the evening sky? 4 light minutes away, we will spend the night's last thoughts inside that question. There is nothing left to brace for. From here, every step is downhill and soft. There is an experience shared by nearly every astronaut who has ever flown, reported so consistently, across decades and nations and languages, that researchers finally gave it a name. When human beings see Earth from space, whole and blue and luminous, something shifts in them. The writer Frank White, who interviewed dozens of astronauts about it, called it the overview effect, and the descriptions repeat like verses of one song. The borders they were raised to think in are simply not there. The atmosphere, seen edge on, is impossibly thin, a film of breath on a stone, and a feeling arrives, sometimes overwhelming, that the whole world is one small, fragile, single place, and that everyone who has ever lived there, together. Astronauts have wept at that window. More than a few have said the view quietly rearranged the rest of their lives. Our settler, standing at a Martian window tonight, is 50 million miles past that experience, holding a version of it no human being has yet known, not Earth, the globe, filling the glass with oceans and weather. Earth, the point, everything, gathered into a single star. And so the last real question of our night is not about fuel or bone. It is this: when all of it becomes one light among the lights, what happens to the word home? I do not know. Nobody knows. Honesty was the first promise of tonight, and it will be the last one kept. But we are not without lanterns here. because human beings have carried home across impossible distances before, and they left us their letters. The emigrants who crossed the Atlantic in the 1800s wrote home for decades. And the historians who read those letters by the thousands find something tender and remarkably consistent in them. Home did not stay a place. It condensed. It became portable. A song sung at the right season. A recipe insisted upon, with ingredients that never tasted quite right in the new country and were treasured anyway. A holiday kept stubbornly on the old calendar. In the new land, year after year, the old country compressed itself, like light into a star, into a handful of things, small enough to carry, and the carrying itself became a kind of homecoming that needed no ship, and we already know the settlers would do the same, because in the sealed rehearsals, they did. In the Mars 500 module in Moscow, and under the White Dome on the Hawaiian volcano, the crews marked birthdays and holidays with almost ceremonial seriousness. And the researchers watching noted that under isolation, celebration stops being decoration and becomes structure, something close to load-bearing. So it is no great leap, and I make it openly as imagination, not fact, to picture the festivals of Mars, a Thanksgiving whose every dish was grown in a buried greenhouse. The mint and the lettuce we met earlier tonight at the center of the table, a Christmas morning under a butterscotch sky, a 4th of July with no fireworks, but with something better rising in the west after sunset. Earth itself, the evening star, attending the party. It started, and between the festivals, the letters would flow, both ways, as they always have. 20 minutes out, 20 minutes back. We spent a whole chapter, earlier, feeling everything that delay takes away. And it takes real things. But fairness asks us to see, here at the gentle end, what it might give back. A conversation vanishes across that distance. Yes, but a letter is not a lesser thing than a conversation. It is a different thing. A letter is composed, one thought placed carefully after another. A letter waits, patient in the dark, to be opened when the heart is ready for it. The emigrant families of the 19th century lived whole lifetimes on letters, and some of the truest things human beings have ever said to one another were said that way. Slowly, across an ocean, with time enough to mean every word. The settlers will not have our instant chatter. They may, instead, recover something our own century has nearly talked itself out of. So gather it all in now, softly, because this is the shape of the answer, as near as tonight can come to one. Home, for the settler, becomes 3 nested things, worn like layers against the cold. The habitat, warm and humming, the small home of hands and cooking and daily life. Mars itself, growing familiar, soul by soul, the home of the body, as the body, we know now, slowly and literally becomes Martian, and Earth, the blue star in the evening, the home of memory, condensed and carried, present at every festival. 4 light minutes and no distance at all from the heart. 3 homes, one inside the other, and perhaps that is not so foreign after all. You have layers of home yourself, and you are lying in the innermost one right now. The room around you, the town beyond the window, the childhood somewhere behind it all, reachable only by memory, which never once needed a rocket. The settlers would simply stretch the layers further than anyone ever has, and trust them to hold. And they would hold. That is not a scientific claim, and I will not dress it as one. It is a bet, placed with open eyes, on 10,000 years of evidence that human beings, wherever they have landed, on tundra and atoll and desert and ice, have made a home of it. Every single time. One chapter remains. And it is hardly a chapter at all. It is just a walk back to where we began. One last look at the sky above your roof. And a good night. The story is finished. All that is left is to set it down gently. So here we are, at the quiet end of a very long journey. And I want to close it exactly where it opened, with the small red light above your roof. It is still there tonight, patient and unhurried, precisely as it was when we began. But you know it differently now. You know the 26-month heartbeat of the road that leads to it. The clockwork door a shy engineer in Essen sketched a century ago. You know what the crossing costs a body. The thinning bone, the silent radiation, an instrument measured on the actual road. You know that nothing has ever risen from that red ground into space. And what it would take to change that, and why the ledger leans, always and gently, towards staying. 4 doors, none of them locked, all of them heavy, and the honest conclusion resting against them. The first people who go should plan on it being forever, and should board, if they board, the way emigrants have always boarded. Eyes open, ticket read, hearts already carrying home in the portable form, and some of them will board. That is the one prediction tonight makes without any hedging, because it is not really a prediction at all. It is just the oldest pattern we have. They will be ordinary. The way the Mayflower passengers were ordinary. The way the families singing through an American wake were ordinary. And one of them may be a child who is asleep somewhere on Earth tonight. This very hour, under this very sky, with a poster of the solar system on the bedroom wall. Here is the last thought, the one to fall asleep holding. When they go, they will not really have left. Mars and Earth are 2 shores of one small sea, the settlers, and someday the child born under 2 hurrying moons, and you, in your bed tonight. All circle the same ordinary yellow star, warmed by the same fire, 8 minutes old when it touches your window, a dozen or so when it touches theirs. Every sunrise that ever comes to Mars is the same sunrise that will find your room a little later this morning. The same light, passed between 2 rooms of one house. Nobody who lives by your sun is truly gone. They have only moved to the far room and left the door of the sky open. You do not need to remember any of it. The windows, the doors, the numbers, let them all drift loose now, like the day itself. They will still be true in the morning, and Mars will still be there, and so will you, resting safely on the near shore of the sea that others will one day cross. If tonight's journey gave you a little wonder, or helped the weight of the day come loose, then it has done everything it hoped to do. And if you would like more slow nights like this one, a quiet like or a subscription helps the next journey find its way to you, and to others who fall asleep among the planets. No pressure at all. You were exactly where you belonged tonight. The red light will set in a few hours. The sun you share with it will rise, And somewhere between those two events, may you sleep the deep, easy sleep of someone who lives. For now, on the friendly side of the sky. Good night. Rest well, under the same sun.